Hello again. Just had a couple questions there, so just getting started here. But again, my name's Clinton Dow. I'm on the geoprocessing team, and I work a lot with Python, so I'm here to talk more about Python and package management using Conda in ArcGIS Pro. So I'll just start today with an actual overview of Conda and how it fits into ArcGIS Pro, the story that we had in mind behind the actual use case, and then look a little bit into the terminology around what Conda does. It's quite a bit of a higher view look at Conda than the workshop yesterday. So if you are looking for in-depth information about how to do specific things, this might not be the best talk, but again, I'm happy to answer questions afterwards. So to start with, let's just talk about what Conda actually is. It's a virtual environment and package manager, and essentially what that means in very simple terms is it allows you to have multiple instances of Python and the supporting files, the packages, installed on your computer in parallel. And essentially that frees you up to move between these environments as you're developing and only consume what's present in them. So you can have multiple versions of different packages in these environments, or even multiple versions of Python in these environments, and test your tools or whatever you're working on against each individual one. Or also just to quickly create an environment, fill it up with all the things you need, and just start testing, making some prototype tools and applications. So there's a huge ecosystem out there of Python third-party code. Everything from Twitter interactions to scientific computing to data science libraries. So Conda is really a curated list of those packages that support scientific computing for the most part. So when you're actually using Conda, you can be sure that someone's gone through and found the best of that Python functionality and then brought it into the package manager. That said, the rest of them are still accessible through pip, which is a different package manager, but it lacks some of the deeper functionality of Conda, so we decided to go with Conda for that reason. One of those bits of functionality is the dependency handling. Oh my goodness. I'm sorry, my slides didn't show up there. Okay, I'm not sure why that's happening, technical difficulties, but so this is what I'm discussing here. So as I was saying, it's automates the dependency handling, and essentially at that point in time makes it a lot easier to be sure that the packages that you're working with will actually work as intended. There's many cases where you'll have a tool and then send it to someone and it doesn't work on their machine because they just don't have the same environment, the same packages as you. So in this case, you can actually just send them the information about the Conda environment. They can create it almost instantly and start to run that tool immediately. There's also a larger set of functionality that Conda is built into called Anaconda. And Anaconda essentially is a GUI built around Conda, so similar to what we have put in Pro, and also includes all of the packages that Conda comes with, or that Conda curates. So essentially, at that point in time, you're not even having to call out to the internet to load those, so it's great if you're wanting to develop remotely or on the road or on a plane or something along those lines. It's all open source, it's written in Python, and it's created by a company, a business partner of Esri's called Continuum Analytics, who also provides a lot of the really interesting packages that are available through Conda. So some of the product story that we were considering when we started developing Conda is essentially ArcGIS is really heavily dependent on Python. There's a lot of different moving parts under the hood that depend on Python. But unfortunately, that also implies that we're kind of locked into the versions that we've developed the version of ArcGIS on. So you'll probably notice, especially in 10x, that there's in some cases will be a few versions behind the most recent Python version, and that's actually by design. Just in case any bugs creep up, we don't want them to propagate out immediately into ArcGIS. So at that point in time, it started to become apparent that if people were wanting to use these third-party Python packages, that it was going to be very difficult, because if something broke, that it may mean that they'd have to reinstall the entire application, and that would actually discourage a lot of people from using Python. So had to look at a different way to do it. So as the Python ecosystem becomes more robust, and it's continuing to do so with data science, machine learning, and more scientific libraries, there's just more and more value that we as GIS developers can get from Python. So in combining these two things, you're not only making your life easier, but you're also saving money for your organization. And the last thing that's still in the works, but more so what we were talking about at the plenary yesterday, or I should say Margine was talking about at the plenary, was the packaging and sharing of these tools as well. So because it handles all the requirements and dependencies, it's a lot easier to share your tools, as I'd mentioned before. And also that distribution now just becomes a single command that people can run, or a part of the actual ArcGIS Pro user interface, which makes it a lot easier to not only get it to people, but also to encourage them to use it. So now I'll just quickly talk a little bit about terminology that we use in Conda, well, just package management in general. Virtual environments is the first one that was actually just brought up in the previous questions there. So essentially, a virtual environment is kind of like those terrariums on the side there. They're ecosystems that have been removed from one another. There's maybe some components, like the soil is the same, but everything that's growing in it is substantially different. So it's also kind of similar in concept to a virtual machine. So it's like a light version of a virtual machine. Rather than encapsulating an entire operating system, it's just encapsulating a slice of that operating system. As I mentioned, it allows for multiple Python versions on your machine, and also allows for configurations of each of those to vary as well. One of the big things that Conda does that virtual environments don't is that it has a satisfiability solver, which actually makes sure all of the different versions are in there. So that's actually a fairly complex piece of the code. And because it's open source, you can actually go in and look at it. It's very interesting. And all of this behind the scenes is really just folders on your disk. It's not too fancy. You can essentially create these environments cheaply. It's as cheap as creating a folder, and essentially that makes them a lot more disposable and iterable. So if something's not working, just change one package in it and try it again, and go from there. Also, they become more easy to replicate with metadata, and as I'll show you in just a moment, there's the whole structure kind of aligns with that concept. Now, packages themselves. Originally come from the Unix and Linux world. And basically, it's kind of the idea that you've got just a very basic kernel of functionality that drives the whole experience, and that you can just add stuff on top of that will enhance your experience. So in the same vein as the Linux and Unix package managers, they're not Python exclusive. You can use anything in them, and also other languages use package managers. So if you come from a JavaScript background with Node, you may be familiar with NPM. If you're from a Visual Studio background, you might be familiar with NuGet. They both accomplish the same thing, but for different languages, different platforms, and in some cases, different operating systems. They're also very versioning friendly. They're designed to work with GitHub, or with Git, I should say, not GitHub specifically. And the reason for that is Linux packages were actually, or I should say Git was designed to help facilitate the development of Linux packages and the Linux operating system. So it's kind of taking all of those ideas over to Python. So you can have each version of your package installed differently and run different tests on it, and that becomes very powerful. It's really, in a lot of ways, similar to shipping a package from a retailer. So if you have a packing slip and you go through it, check everything off, stick it into a box, that's what you're doing. And then on the outside, you kind of want to provide some information, the ingredients, let people know what modules or packages are within it. Some warning labels, if it only works with a certain version or if it's a beta version, just put something on there to indicate that, and also instruction manuals that come along with the documentation. So as I'd mentioned, we're just take a quick look at the package structure here. It's a basic overview, but essentially you've got different folders there that all contain a little bit of the metadata. So up top, you see there's the Git hidden folder, and that actually contains all of your version control information. The next one down is just for my IDE. I personally use PyCharm quite a bit. And then everything under that is what we're really interested in for this talk. So you can see there's a data folder, sample, tests, and then the actual metadata that defines how the package is created and shipped out. So you can see here that there's the meta.yaml, and that's kind of the recipe in which you explain how everything gets packaged. If you are interested in learning more about that, the workshop that myself and Sean Walbridge did last night will be available on Esri video, and it goes into a lot more depth on the actual process of packaging things. But at this point, it's really just to indicate that all of this stuff is just folders and basic files. There's not anything really complex happening. There's the concept of channels as well. So essentially, that is where you're having the packages served from. It's kind of similar in concept to TV channels. You have a related group of functionality or a related group of shows that get pushed out through these channels and get consumed. And there's also the notion of public versus private channels, kind of free on air versus paid cable or something along those lines. Public channels in the Conda context are hosted on anaconda.org, which is Continuum Analytics, one of their many sites. The channels there are free to create, and they're kind of similar in concept to a public GitHub repo, in that you're wanting to put each version of your release up there, and at that point you're committing to that release that people can use this, and you're not going to change what happens in that version. So it's not a place to test things so much, but it's more a place to actually put things out for public consumption. If you're wanting to do more on the testing side or control access for a number of reasons, it could be for subscription or a beta test group or for any other reason, then you'd want to look at using private channels instead. And all that is, it's super simple. I could tell you how to set one up in 10 seconds. It's just a web server which hosts the packages, and at that point, it becomes as customizable as any other web service. So if you do go look at anaconda.org, it's basically doing just that. They've set up this kind of social site around the repositories that are hosted through those channels. So to kind of help with the access and all of that, you can use any web services like IIS or an Apache web server or anything along those lines. Put access control in there, put groups, also opportunities for telemetry where you're getting feedback, to see how many people are downloading those packages and everything along those lines, and perhaps more in-depth information if your web application does so. So here's just a quick screenshot from anaconda.org of the Esri organization. There's, again, kind of similar to GitHub, there's organizations and then contributors. So organizations are generally where the public commits get released, and then the contributors are more on the personal level. So that's where you're actually putting stuff out. Like, for example, if you had a demo for a talk that you're going to share, it would be more appropriate to put it on a personal channel than on a public organizational channel. That's how you define channels. It's a text file that's maybe 5 lines long. It's in YAML. That stands for yet another markup language, if you're interested in learning more about that. And essentially, so you can see there's 3 types there. There's the first channels that are actually the anaconda.org usernames. Also, that defaults one is important because that is where all of the continuum curated packages come from. The private servers, on the other hand, would be the third one down on that list. That's actually setting up the HTTP server and then using a URL as you would in any other place. And then the last one is where you can actually just have a tar.bz2 package locally on disk and then install it that way. And that's very handy in case, for example, you're in an air-gapped environment where you're not networked, connected to the internet. You can still serve these out by, either having them on a network share or, even just giving a USB drive with them. So when you're setting up a private repository, like I said, it's just a web server. So this is a screenshot from the Continuum repo site. And all it is a bunch of those tar.bz2 files. And the one step that has to be done to make it work with Conda is just to run conda index on that directory. And that creates the repodata.json file that you see up at the top. And that just includes all of the package metadata. You should also care because it makes your tools and your processes a lot more scalable as well. So in my opinion, packaging makes things a lot more easy to deploy as web services, and I'm hoping that will go along with that more in future versions. So as we now have the deploying mechanisms in ArcGIS, they're not currently in Pro. Those ones are being ported over, but there's also the opportunity to use these packages as well. So we're looking at ways to do that. If you're setting up new workstations, new hires, this is a perfect way to save a lot of time there. Essentially, you can just have everything packaged, and I literally mean everything from onboarding documentation to their configuration for IDEs, so on and so forth, and deploy those through packages. It, again, is scalable in its distribution, so you can put it up on the web server, and if only one person uses it, so be it. Or if 1 million people use it, then awesome. But at that point, it's a web server. You don't have to handle each and every one of those people individually. It allows you, again, to use those open source Python packages, and it really does translate into a lot of savings. There's literally thousands of packages out there of varying utility and everything, but generally speaking, if you're not having to rewrite that code, it's a good thing. And Conda itself is really becoming an industry standard as far as I've seen. So it kind of means that when you're bringing people into the organization, if they do have a Python background, that they've likely been exposed to it in some context. So that should, over time, make things just generally easier, kind of increase the familiarity, excuse me, across your team, and then also lowers the cost and complexity of onboarding technical employees. So just a quick moment to. Oh, can everyone hear me here? Sorry. Just a quick moment to look ahead at what's coming with some of this. So in ArcGIS Pro 2.0, we've got the alpha out right now. However, it doesn't include these enhancements yet. Most of the work we've been doing on the first couple iterations have been in the packaging side of things. So essentially, this will allow for enhanced environment control in the user interface, and I will show the user interface in just a second here quickly. And also, as was demonstrated in the plenary yesterday, integration with R tools using the RPython bridge for ArcGIS, so you can just deploy R tools as as Conda packages as well, and use the essentially the R bridge in a very basic Python script to import that functionality. And then in 2.1, we're hoping to add packaging and channel support so that it's a lot easier to create and distribute your packages and then also consume them from other users. And also looking at creating ArcPy as a package as opposed to the coupled code that it is with the application right now, which should also really open up things that you can do with that. All right. I'll just jump over to the application here quickly. All right, and so this is just a quick look at the UI in the backstage of ArcGIS Pro. Essentially, as I said, is modeled after Conda, which is Continuum Analytics product. And it has a lot of the same categories on the left-hand side there, so you can just see what you've got installed at a glance, update those packages if there's any that currently need updating, which it doesn't look like there are right now, or install this whole suite of packages. So this is all the curated list that I referred to earlier. Now, just to show that you can actually install, let's see. Is that? Yeah. So that's the package that we created last night in the workshop. So that's up on the Esri channel currently, the Conda Dev Summit 2017 talk. So I'm going against my own advice there, but that was actually by design. We wanted to show that how to publish to the different types of channels. So if I just hit install here, this screen is doing weird things to my application. Oh. Then we'll see it just pops up with a quick dialog here just to show you the open source license. It's important to point this out. The open source licenses that these use are not the same license that Esri uses. So if there's that consideration in your organization, if you have intense security concerns or anything along those lines, that you'd want to review those ahead of time. And that also up here, it will just mention the dependency chain as well. So you may just want to take a quick look there and make sure that you can't anticipate any collisions occurring from that. So once we hit install here, we can see that it'll take a moment and install. Also worth mentioning, there's no metadata here just because we created that package really quickly, but I'll show you in a second. It does actually populate with meaningful information for pretty much all of the packages. We actually went through for the ones that were missing it and added it as well. And so essentially then what that does is at that point in time, it makes these tools actually work. So we've got the package now that kind of plugs into that tool interface, either the TBX or the PYT. And then if I just run this tool very quickly, should just start working. Oh, what's it? Oh, system 32, that's why. Sorry, I'll just pull this over to my screen really quickly here. But yeah, essentially it's just a tool running. It's nothing super fancy, so no worries if you miss it. Okay, there we go. So just had to get the proper file name in there, hit run, and if all goes according to plan, that it will pop up with a distribution model of South America in just a moment. Oh, all did not go according to plan. Yes, I'm not sure. Something's odd is happening here with my computer. It's saying it can't find the desktop location. So apologize for that, but it certainly does work when the computer itself is working all right. And an example of that is available on the workshop from yesterday. So with that, that's all I've got. So if anyone has any questions, I'd be happy to answer them. I think just one. There you go.
If ArcGIS is going to become a package, does that mean it can be run independently from a licensed machine?
No. So essentially, under the hood, ArcGIS hooks into the DLLs and everything that we use. So it'll still require that installation to be there. It's just essentially going to make it a lot easier to ship those packages that depend on ArcGIS, because that way you can start specifying the version of ArcGIS as well, so then you can be sure that it'll work with the different versions of Pro.
Okay.
Any other? Oh, okay, we've got a few here.
Is there any advantage or problems when you install Anaconda on your machine at the same time as using the one that's embedded in Pro?
There can be. It all is just based off the path that you're using, essentially. So if you're just including only the Pro installation as the first instance of Conda in the path, then that should be fine. But I have seen it where Pro has been installed, then Anaconda or Conda has been installed over top of that, and then it's just a little bit confusing. So it's really just the path that it comes down to. And one over here.
I have two questions. The first one regarding ArcGIS Pro and then the old desktop. At the moment, we're using the virtualized environment, but we could shift to Conda, but we are still using ArcGIS Desktop and not yet Pro. Would that be an advantage?
So do you mean using Conda, an independent Conda with 10x? Is that what you mean?
Yeah.
Or, yes, that's possible. It's fairly technically involved though, so it has a lot to do with the .pth files that are present in the site packages directory. So if you're going into Python 2.7 on your C drive where it'll typically install, and then look in site packages in there, there's several files that have .pth, and those basically just kind of act as symbolic links in a way. So they're setting the path at that point to where the DLLs are. So if you can include that information in your packages, that will work all right. But like I say,
So
it's
basically
not
you're
something
saying
that
don't
we're
go there.
really trying to encourage right now.
And then the next question, the demo you did yesterday, I wasn't here, but I would very much have liked to see the workshop. Should I understand it so that it's free if you use this, or can we find it somewhere on the internet?
What's that? Sorry?
Oh, that's why you have to pay for all the videos. So sometimes when people they say it's available here.
Oh, I was not aware of that. So, I'll have to look into that. I can get that information to you afterwards here.
Okay.
Thank you. All right, and that's everything, I guess. Doesn't look like anyone else has any questions, so thanks very much for coming.